Hello students, welcome in math class. Students, we are doing a topic geometric progression of chapters sequence and series, and we have completed its objectives, that is, first, to check the series for GP or not. Second, to find the particular term using general term formula. Third, to find the number of terms. Fourth, some important questions were discussed. Fifth, to find the nth term from the end. Then sixth, sum of first n terms of GP. Seventh, sum of some special sequences. Eighth, sum of infinite terms of GP. Then we find a rational number for recurring decimals. Then we have done geometric mean. 11th, relation between the arithmetic mean and geometric mean. Students, today we are going to start with the very last type, that is the statement sums of GP. Let's start with its first sum. If the 4th, 10th and 16th terms of a GP are x, y and z respectively, prove that x, y, z are in GP. Now here, firstly they have given 4th, 10th and 16th term. So, let A is the first term, R is the common ratio, and general term formula we know that Tn is equal to A multiplied R raised to power n minus 1. Now firstly, for the 4th term is x, so T4 is equal to x. Here put the formula, that is AR cube is equal to x. First equation. Similarly, 10th equation term is given y. So here AR raised to power 9 is equal to y. That is the second equation. 16th term is given z. So 16 can be written as A into R raised to power 5 is equal to z. Now we are having three equations. We have to prove that x, y, z are in GP. Now for proving x, y, z are in GP, we have to prove that their common ratio is same. That is y upon x is equal to z upon y is same. Now firstly we have to find y upon x. So divide second term by first term like this. So we get A r raised to power 9 upon AR cube is equal to y upon x. So A cancel with A, R9 and R raised to power 3. Bases are same. It is in the divide, so powers will be subtracted. So y upon x will equal to R raised to power 9 minus 3. So it is R raised to power 6 is equal to y upon x. Now for second ratio, z upon y, divide third by second. We get z upon y on the left hand side, AR raised to power 15 divided by A multiply R raised to power 9. Here A cancel with A, again bases are same, so powers will be subtracted. So 15 minus 9 we are left with R raised to power 6 is equal to z upon y. Now y upon x is equal to r raised to power 6 and z upon y is also equal to r raised to power 6. So both these ratios are equal. They show that x, y, z are in GP. Now let's take the second example. The first term of a GP is 1. The sum of the third and fifth term is 90. Here sum is given of third and the fifth term. We have to find the common ratio of GP. Here common ratio we have to find. So suppose that R is the common ratio. Now here first term is given. So value of A is given. A is equal to 1. Then sum of third and fifth term is given. That is 90. And we are having general term formula Tn is equal to A multiply R raised to power n minus 1. apply for the third and the fifth term. We get AR square plus AR raised to power 4 is equal to 90. We are having a value of A, so when you put the value of A that is equal to 1, we get an equation here R square plus R raised to power 4 is equal to 90. When you shift 90 on one side, we will get an equation. Now, it is a quadratic equation, but it is in R square. Now, for solving quadratic equation, we have to apply the sum product rule. Sum is equal to plus 1 and product is minus 90. So, for positive sum, we require the factors plus 10 and minus 9. R is to power 4 plus 10R square minus 9R square minus 90 is equal to 0. Now, from the first two terms, R square is common. So, we are left with R square plus 10. From the last two terms, minus 9 is common. So, R square plus 10 is equal to 0. Now, factors are R square plus 10 and R square minus 9 is equal to 0. When you equate them equal to 0, we are getting R square plus 10 equal to 0. From here, R square is equal to minus 10. Now, when you shift square root sign this side, you will get the negative term under square root, which is an imaginary number. So, this value of R is rejected. Now, from the second factor, R square minus 9 is equal to 0. When you shift 9, you will get R square is equal to 9. When you shift the square, it will become square root. So, we are having two values. R is equal to plus minus 3. So, common ratio will be the plus 3 or minus 3. Let's take one more example. A person has 2 parents, 4 grandparents, 8 great-grandparents and so on. Now, find the number of his ancestors in the 10th generation and total in 10 generations preceding his own. Now here, statement is given, a person has 2 parents, 4 grandparents. It means in the first generation they are having 2 members, that is 2 parents. Then in second generation they are having 4 grandparents. 4 can be written as 2 square. In third generation they are having 8 great grandparents. So 8 can be written as 2 raised to power 3. In this way we are getting a GP series that is 2, then 2 square, then 2 cube and so on. Now we have to find the number of his ancestors in the 10th generation. Whenever TH is there, we know that we have to find the term. So, Tn is equal to A into R raised to power n minus 1. From the GP series, we can find A is coming out to be 2, that is the first term, and common ratio is 2 square upon 2, that is 2. When you find the mod, you will get it is equal to 2 greater than 1. It will help us to find the sum of the GP series. Now, Tn is equal to A into R raised to power n minus 1. Put the values, we get T10 is equal to A into R raised to power 9. Now, put the value of A and R, 2 into 2 raised to power 9. So, it will become, bases are same, powers will be added, 2 raised to power 10. On solving this value, we will get 1024. It means he is having 10 in 10 generation, number of ancestors is equal to 1024. Now second part is there, we have to find the total number of ancestors in 10 generations. So we will find the sum. Here R is greater than 1. So we will apply the formula. Sn is equal to A multiply R raised to power n minus 1 upon R minus 1. Put the values, we get S10 is equal to 2 multiply 2 raised to power 10 minus 1 upon 2 minus 1. Here 2 minus 1 will be 1. 2 raised by 10 is 1024 minus 1. So we are left with 2 multiply 1023. So total number of ancestors is 2046. Now students, in this way we can do the statement sums. We have to read the statements carefully. Only then we can solve these types of questions. Now students, I hope you are able to solve sums related to all these types of GP. Before starting the worksheet given in SNAP homework, you must go through the links guided in the SNAP homework. Thank you.